Okay, please get out your homework from last night, this proof here. If you'd like, you can get some proof paper in the front there, and you can write down this proof as I do it along in the proof paper, just in case you did it differently than I'm doing it, and you might have questions on whether your way is right or not, and I can certainly answer those when I come back. But if you just want to do this along with me here, that way you know you at least have one correct way to do it, that might be a good idea. So if you want to grab proof paper up front, go ahead and do that. Um, Otherwise, follow along with me and check what you did last night. So first thing you want to do is you want to start with the given. Angle 1 congruent to angle 2, and segment AB congruent to segment DE. And with those being congruent, I'm going to go ahead and mark those on the diagram. AB congruent to DE, and angle 1 is congruent to angle 2. Now, in this proof, we want to prove that DC is congruent to AC. And DC will be congruent to AC whenever the triangles are congruent. So our goal is to get triangle ABC congruent to triangle DEC. And we have 4 justifications that allow us to prove triangles congruent: side, 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 angle, side, angle, and angle, angle, side. So our goal is to get one of those 4. So looking here at the picture, we already have one side, AB, congruent to DE. And I see here that we have angle ACB and angle DCE. Those are vertical angles. And I know that those are going to be congruent. Angle ACB congruent to angle DCE. And the justification for that is vertical angles congruent. So we have this angle congruent to this one, vertical angles congruence. So looking at that, seeing as how we now have an angle, I can eliminate the possibility of us doing side, side, side. That still leaves 3 in place: side, angle, angle, and angle, angle, side. I am going to take out side, angle, side, just from the fact that we have information about these outside angles. Angle 1 and angle 2 are exterior angles to this triangle. So whenever I look at angle 1 and angle 2, we have information about them. They're congruent. So if I were to push that given, that would mean that they're equal. And now that they're equal, I look and I ask myself, what do I know about angle 1 and angle 2 looking at the picture? Well, I just got done saying that angle 1 and angle 2 are exterior angles to this triangle. Now, we have a theorem that tells us exterior angles are going to be equal to the sum of the 2 non-adjacent interior angles. So what that means to me is that angle 1, right here, is going to be equal to angle A plus angle ACB. So the measure of angle 1 equals the measure of angle AC, and measure of angle A plus the measure of angle ACB. And the justification for that is the exterior angle theorem, which we studied earlier in this chapter, which once again said the exterior angle of a triangle is equal to the sum of the 2 non-adjacent interior. Angle A and angle ACB are interior angles. Angle 1 is going to equal the sum of those 2. And then the same is true for angle 2. Angle 2, if I look at it, angle 2 is right here. Angle 2 is going to equal angle D plus angle DCE. And that is the same justification. So angle 1 equals A plus ACB, and then angle 2 equals D plus DCE. Now, looking at this here, we have D plus DCE equaling 2. And we know that angle 2, the measure of angle 2, equals the measure of angle 1 up here in step 3. And we know that the measure of angle 1 equals A plus ACB. So we have all of this, I'll call all of this A, equaling B, which is the measure of angle 2. The measure of angle 2, which is B, equaling the measure of angle 1, that's C. And then the measure of angle 1, which I'm going to call C, is equaling measure of angle A plus the measure of angle ACB. I'll call that D. So A equals B, B equals C in step 3, and then in step 4, C equals D. So that means through the transitive property, I can say the measure of angle D plus the measure of angle DCE equals the measure of angle A plus the measure of angle ACB. And that's transitive. Now, looking at this, how does this help us? Well, if I'm looking at this picture here, if I can get angle D to be congruent to angle A, if I can get those two angles to be congruent, you'll see here that that gives us angle, angle, side, angle, angle, side. And the two triangles are congruent. So I want to get angle A to be congruent to angle D. So angle A right now is right here, and angle D is right here. I just need to get rid of DCE and ACB. Well, luckily up here in step 2, we know they're congruent because they're vertical. That means they're equal. So the measure of angle ACB equals the measure of angle DCE, definition of congruent angles. And now that they're equal, now we can do a substitution step. I can take DCE and put it in for ACB. So we have the measure of angle D plus the measure of angle DCE equals the measure of angle A plus the measure of angle DCE. And all I did is I took, in step 6, I took ACB out and put DCE in its place. That's substitution, steps 6 and 7. Step 9, we can now subtract out the measure of angle DCE. So we have the measure of angle D equals the measure of angle A. That's subpo. And since they're equal, we can make them congruent. Definition, congruent angles. So now we have D congruent to A. So like I said, that now gives us angle, angle, side. So the two triangles are congruent. Triangle ABC is congruent to triangle DEC, angle, angle, side. And with the two triangles now congruent, we can now say what our proof statement is. DC is congruent, segment DC is congruent to segment AC, and the justification is CP, CTC, corresponding parts of congruent triangles are congruent. So that was the proof you had last night for homework. If you need to, you can rewind the tape, you can pause it to copy down anything you might need or need re-explained or reheard. What I would like you to work on now in class is the next proof in your packet, where you have to prove triangle PRS is congruent to triangle QSR. And I want to start you with the given on that. And the given is that angle SPR is congruent to angle RQS, and that segment ST is congruent to segment RT. And once again, you have to prove the triangle PRS, which is this triangle right here, PRS, is congruent to triangle QSR right there. Okay, now, you can use proof paper for this, or you can do it in your note packet if you'd like, and you may work with a partner if you would like to on this as well. What you do not get finished of this proof is homework, and once again, if you need to, you can rewind the video or pause the video if you missed any part or need any part repeated. Once again, what you do not get finished with this proof is homework.